Now that we have discussed some basic mold components, let's look at some of the machining practices for building molds. Milling provides a way to remove large amounts of steel very rapidly. On small parts, milling brings a part to roughly the right dimensions, but another more precise machine operation is needed to bring the steel to its final dimensions. For this reason, milling on small parts is referred to as a roughing operation. However, large plastic parts generally have wider tolerances, which are met acceptably by the milling process. Milling is done prior to heat treating because it is difficult to machine the steel in its hardened form. This is why it is beneficial to remove as much steel as possible prior to heat treating. Typical operations prior to heat treating include drilling water lines, ejection pinholes, and machining pockets for inserts. The part to be milled is mounted on a milling table, which moves left to right and up and down. Turning the steel in a lathe is also considered a roughing operation. This process also leaves a swirl pattern on the steel. However, it is a preferred method for rapidly removing large amounts of steel from cylindrical parts. Grinding is the most accurate method of machining steel. Steel is ground in the hardened state because the abrasive stone wheel works best on hardened steel. Grinding soft or unhardened steel tends to gum up the wheel, requiring the wheel to be redressed with diamond. Since diamond is harder than the abrasive stone grit, it is used to clean and shape the wheel. A radius dresser allows us to accurately machine a radius or form on a grinding wheel. Another accurate method of machining is called electrical discharge machining, or EDM. EDM allows us to machine difficult forms into any steel, whether soft or hardened. The first step is to machine a carbon electrode. Electrodes are easily machined and can be made quickly and accurately. Grinding is the method of choice for machining electrodes because of its precision and accuracy. The electrode is a mirror image of what is to be machined into the steel. The electrode represents what the actual part or detail would look like once molded. The EDM operation removes steel by passing a series of electrical discharges between the electrode and the steel at a controlled interval. Both the electrode and the steel are submerged in a dielectric fluid. Electrical discharge machining equipment is very expensive, and the process is extremely time-consuming. Once the steel has been machined, the surface finish of the steel must be reworked by hand to eliminate the grit-type finish. Final handwork is required after the cores and cavities have been machined. Since the molded part's finish is dependent on the surface finish of the mold, stoning of the cores and cavities is done using progressively finer stones to achieve a desired surface finish. Polishing stones are made of fine stone compressed into a stick form. A diamond paste can be used to work the steel to a flawless type mirror finish.